Okay, here we go. So, in the last lesson, we started to look at graphing trigonometric functions. And what we saw, we looked specifically into y equals sine x, y equals cosine x. We saw some basic stuff, including the general shape, which is called a sinusoidal wave. And it just kind of up and down, up and down. Remember, repeats forever and ever. It has a period of 2 pi, and then we actually used 4 videos to talk about, well, how can we manipulate or change the equation to stretch it, shrink it, move it up, down, left, right, all that good stuff. Um, we're on to the next lesson. We actually have 4 more trig functions to look at. So bad news, good news. Bad news, maybe these are a little tricky and we're going to pack all 4 into one lesson. The good news being, because that's a little tricky and tightly packed, we'll keep things pretty basic. And the best news of all is that I'm going to remind you guys that you have these, and these can be super helpful when graphing trig functions. So I'd at least like you to see the basic shape of some of these and look through some of the properties. This is all lesson 4.6. We'll do 2 of them in the first video. We'll do 2 of them in the second video because they both kind of have their own similarities. So hopefully you have the notes that you received already. Maybe you have them pulled up, and we're going to start out looking at y equals tangent x and y equals cotangent x. And you may or may not remember when we did right triangles, tangents is part of SOHCAHTOA. So remember, in right triangles, the tangent ratio is opposite over adjacent. But maybe more importantly to look at now, our discovery when we did the unit circle, when we did that trig wheel just a few days ago, what we were seeing was that tangent is equal to sine x over cosine x. All right, that's really important. We could kind of graph tangents using that knowledge, sine x over cosine x, but we also, again, have our calculators that they do conveniently have a tangent button. Let's just take a quick look. One of the things I want to remind you or inform you about tangent is that while sine and cosine have a period of 2 pi, they go all the way through 2 pi before they begin their cycle over and over again. If you go and calculate tangent, you can use your special trig wheel and do those calculations of sine divided by cosine and find out the tangents. You'll see that after pi, it starts the whole cycle again. So the period is actually half as long for tangent, and it's going to be the same for cotangent. The period is pi and not 2 pi. And we'll see that in our graph a little bit. I would love to maybe graph both of these on top of each other so you can see how they relate to each other, but I didn't want things to get super crowded or busy. So here's what I did. I made a y-axis, and then I'm pretty much just going to graph 2 of them, one over the other one, and so you can see how they relate to each other. And again, I want you to see the basic shape of them, but then as we get to doing these for practice and homework, I'm going to remind you how useful your calculator will be in helping you out with that. So let's take a look. You can go do the calculations, but take my word for it right now. At 0, right at x equals 0, the value of tangent is also 0. And so I'm going to put a little marker there for my tangent graph. And I told you guys that the period is pi. And so I might be inclined to go from 0 to pi to show you one cycle of tangent. But it turns out, and you'll see this in a little bit once we make our graph, it actually is probably going to be a little easier for you initially to see as it goes from negative pi over 2 to positive pi over 2. Let me mark a couple of those in. Half of pi is pi over 2. And so hopefully you're pretty easily convinced that if I went from negative pi over 2 to positive pi over 2, that's also a jump of pi. All right, I just took this and I kind of slid it back half a space. That's going to be a little bit easier to see what's going on because at 0, tangent of 0 is 0. All right, at pi over 4, that's 45 degrees. Maybe some of you guys remember that. But at pi over 4, you can look at your wheel again. The tangent is actually 1. All right. So if I made a 1 here, that would be tangent right there. At pi over 2 or 90 degrees, if you do the math, you're going to see that tangent of x is undefined. We can't graph it. All right. And it turns out, you guys might remember, a lot of times when we had undefined on the graph, it turned out to be a vertical asymptote. It is here. And so I'm going to draw a dashed line there and just show you that that's a vertical asymptote. And over on the other side, we've got some similar things going on. Again, you can do all the math if you feel like it to calculate the values of tangent. But at negative 90 degrees or negative pi over 2, there's also a vertical asymptote. And at negative pi over 4, or negative 45 degrees, it turns out that tangent is negative 1. So again, I'm going through this kind of quick, but here's the deal. Here, it's undefined. It actually shoots forever down to negative infinity. Here, it's at negative 1 at x equals negative pi over 4. At x equals 0, the value is 0. At x equals pi over 4, the value of tangent is 1. And then at x equals pi over 2, it shoots up to positive infinity. If we graphed all the points in between, what we're going to have is we're going to have a shape that kind of looks like this. All right, it comes up from negative infinity, goes through 0, and then shoots up to positive infinity. I didn't draw that super well, but there's better diagrams in your book. You can go take a look. And then the whole cycle is going to start again. All right. So that means that, again, we're going to go from negative infinity, hit 0, and go to positive infinity. And I could keep drawing those to the left also, but we're just going to have that process over and over and over again. So I'm looking real quick at the notes. You can see what y equals tangent x looks like. And again, just want to remind you, if I graphed it from 0 to pi, I would have seen this piece and then this piece right back to the start of the cycle, but it's maybe easier to see one full connected piece of it, which is why I went back to pi over 2. But what it says in our notes about some of the properties, first of all, a reminder, the period is pi. The domain, x values, well, this is going to go on forever to the left and the right. So I'd love to say all reals, but I notice right here, actually, I don't have an x value. I can't graph it. It's undefined. And here, and so that's a little awkward to say. It says the domain is all real numbers except where there are asymptotes, which occur at pi over 2, and then multiples of pi to the left and right of that. Okay, that's the best I could do. But I do want you to recognize, yep, it goes forever left and right, but there's these parts where it's not defined. And so we have to say in the domain, x cannot equal those things. As far as the range goes, remember sine and cosine, -1 to +1, that was it. But this goes forever down to negative infinity, forever up to positive infinity. So the range is actually all real numbers. And in terms of x-intercepts, because it continues to cross the x-axis, and the x-intercepts are multiples of pi. There's one y-intercept because it is a function. There's one y-intercept and it's right at 0. So we work through some of the properties of y equals tan x. Again, wanted you to see the shape, want you to understand those properties. Don't worry so much about memorizing it all, but hopefully at least it kind of makes sense to you. And best thing of all is that our graphing calculators have a tan button. And so we can graph tan functions. Remember, please, that your mode needs to be set in radians. We're just doing life in radians right now. And then also want you to get comfortable when we're graphing trig stuff. Please get comfortable with resetting your window. All right. A lot of the stuff we do today, the range window, most of your windows are probably set at -10 to +10. That might be good enough. Maybe you want to go -50 to +50. I don't really care. But when we set the X values on our window, it'd be good to kind of set for 1 or 2 periods or whatever they end up telling us. And then it would be good to set our scale, our increments at places where significant things are happening. So we'll take a look at a couple of examples of those. I think I want to show you real quick the cotangent graph, y equals cotangent x. And very important to remember that cotangent is cosine x over sine x, or maybe even more significantly with our calculator, it's 1 over tangent x. It's the inverse of the tangent function. And if I'm just showing you the basic shape, and I'm going to try to, again, share the y-axis here and graph y equals cotangent x. Well, for tangent at 0, when x is 0, the tangent was 0. So the cotangent is going to be the flip of 0, 1 over 0. And it turns out that's undefined, 1 over 0. So right here at 0, my graph is undefined. Let's maybe use a different color. And instead of making any point, I guess I need to draw myself an asymptote. It's going to be undefined right there. Let me copy over some of my other points. Pi over 2 and pi negative pi over 2. All right. And the crazy thing about cotangents, or how they relate to tangents, look at my tangent graph again. I'm going to bring you up here. At pi over 2, my tangent graph was undefined. Cotangent is going to be the flip of that, which actually turns out to be 0. So it kind of looks like it's the opposite. When tangent was 0, cotangent is undefined. When tangent was undefined, cotangent is 0, which means here at pi again, it's going to be undefined. And then the other crazy thing is it kind of goes in the opposite direction. So cotangent is going to go like this, where it's undefined here. It's going to come down from positive infinity and then go through 0 and down to negative infinity. And it's going to come from positive infinity and go through 0 and come down to negative infinity. And we get that cycle over and over again. So they kind of look the same. They have this elongated twist curve to them, but they're shifted over. They have their asymptotes in different places. And where the tangent kind of goes bottom to top as we go left to right, cotangent goes top to bottom as we go left to right. Let me run you real quick through some of the properties. Again, so they'll be similar to tangent. I don't need you to memorize all of these so much as kind of understand. First of all, the period is pi. After we go through pi, we repeat the whole process wherever we might have started, right? Here I have an asymptote at 0 and an asymptote at pi, and I got one full period in between, and then I'm going to start again. So the domain, because this goes forever left and right, again, it's all real numbers, except we have these asymptotes where it's not defined, and I have to express them a little different. Those happen at multiples of pi. The range, all real numbers, it goes forever to negative infinity, forever to positive infinity. X-intercepts, those are a little different. This time the X-intercepts are at pi over 2, and then we jump multiples of pi to the left and to the right. And so those are the shapes. If you're asked to graph any sort of tangent function, any sort of cotangent function, you should expect to see something that looks like that. If it doesn't look like that, then maybe you should be a little concerned. And we can still do all of the things that we did with sines and cosines, those A, B, C, and D values, still do all of those things. Like they change the period. We don't change the amplitude so much because these go forever to positive infinity, forever down to negative infinity, but we do kind of stretch them out or squish them together. We can slide them up and down the graph with the D value. With the C value, we can slide them to the left or right. We can do what's called a phase shift, but rather than kind of work those out on our own like we did with the other graphs, we're going to let the calculators do a lot of work for us. So that's some good news. I'm going to erase these. I'm going to take a look, and I'm going to ask you to make sure you have your calculator so you can punch some buttons along with me. And when you're asked to graph these for homework, let's just make sure our graphs are labeled correct, but let's make great use of our calculator. So pause the video if you need to get your calculator. Go get your calculator. I'm just going to erase this and run through one or two problems really quick. I'm going to take these problems from the book, and one of the reasons being I want you to punch it on the calculator, but then I want you to be able to see the answer in the book also and see that that agrees with calculator when you enter things correctly. And so I'm going to start with the tangent one. I'm on page 574, and I'm looking at example number 1. Now I'm going to make sure that my calculator, I go to mode and make sure I'm set into radians. I'm going to go to my y equals page and make sure that's cleared out. And the example given says y equals 2 tangent x over 2 and it says, hey, I want you to graph this from negative pi to 3 pi. That's really easily done with just setting up our window the right way. So don't feel like that's anything harder. It says negative pi less than x less than 3 pi. So just point out real quick, this would be our A value, which is not going to be the amplitude. Tangent and cotangent graphs don't have an amplitude, but it will involve just how it's stretched. My B value, it looks a little sneaky when it's written like this, but hopefully you guys can see my B value is 1/2, right? X over 2 means the same thing as 1/2 x. And so you can figure out, although we're going to look on the calculator and let it help us out, the period, instead of 2 pi over b, for tangent graphs, the period is pi over b. So pi over 1/2, the period is going to, if we flip and multiply, the period is going to become 2 pi. All right. Again, no big deal. We're going to use our calculator. And it's going to be as simple as just, the reason I was bringing that up is maybe to impact our window. Do me a favor before we even graph this and go to window. And let's first make note that they want us to graph from negative pi to 3 pi. So let's literally, in our calculator where it says x min, do negative and then we can hit the pi button. That's the second button, and then right over above the caret symbol, negative pi. And when we go down to X max, it may change it so it says negative 3.141592, whatever. We'll go to X max and we'll put in positive 5 pi as my X max. So this is literally going to show me just what I'm supposed to put on my homework, what I'm supposed to graph. And then for the scale, the reason I was going through the B value and showing you that the new period of this changes from pi to 2 pi is that for the scale or those increments, those jumps, we might want to put in pi over 2. We might want to cut that in half or in fourths. Maybe pi over 4 would be the increment. So I'm going to change the scale to pi divided by 4. And so those increments will be helpful. I'm going to leave my y min and my y max at negative 10 and positive 10. And I'm going to take a look at a graph. I was wondering why it didn't come up because I never put it in my calculator. I was busy doing the window with you, but let's go back to y1 and let's put this function in now. We're just going to put 2 times tangent, and we'll do x divided by 2 and close out the parentheses. And now you should have, your calculator might put solid lines or dotted dashed lines for those asymptotes, but you should see this winding S. And that's exactly what you're supposed to put on your homework. It said, please graph this from negative pi to positive 3 pi. All right. So it's really pretty simple when we use our calculators to do the work for us. It's just mostly labeling our graphs correctly. Let's do a cotangent one real quick, or at least let me show you how to set it up in the calculator. Y equals 1/2 cotangent of 2x. All right. If I'm putting this in the calculator, I'm going to put y equals, I'm going to put the 1/2 in because that's not flipped. That's not changed. It's here. When we hit the word cotangent, cotangent is 1 over tangent. And so I'm going to do 1/2. 1 over is the same thing as saying divided by. I'm going to do 1/2 divided by tan 2x. That's the same thing as 1/2 over tan 2x. And if we put that in our calculator, we would have a perfect representation. All right. So give it a practice. Actually, I'm not going to reveal the homework until after the next video, but we'll make good use of our calculators. In the next video, we'll take a quick look at secants and cosecants and how they're similar to each other and how they relate to sine and cosine.